This is the third video of function, and in which we are going to understand about surjective function. That means we will check surjectivity of any function. And regarding that one, initially I would like to just recall the ways of classification by which we did the functions. First of all, first of all, classification classification of functions was as injective. The first one, injective function. And mind it, traditionally the injective functions were known as one function, one function. But nowadays, in place of one function, we are using injective functions, and those functions which are not injective are called non-injective functions. Non-injective functions. Non-injective functions. And these non-injective functions are traditionally known as many one function or many to one function. Actually, the traditional naming system is better to understand the nature of the function. But nowadays we are not picking two functions, we are just taking one function, and the second function is understood as not of that kind. As for example, if you say head and tail, but nowadays, if you say head and not head, that is the process of naming to the kind of these two functions. Actually, the non-injective function is now traditionally known as many to one function. Many to one function. That is many one function. As the name suggests, that one function means each element of the domain are related, are paired, are having their images differently. So actually different elements of domain are having different elements under injective function or one function. But whenever many functions of many elements of domain are associated with one element of codomain, means if two elements or more than two elements of domain, means the first set, are associated, are having same image in the codomain, then we say that this function is many to one function. But nowadays, in place of many to one function, we say that this is non-injective function, and this is better to use. But today we are going to have a discussion regarding onto function. Okay, so regarding onto function or surjective function, we will have this video. Surjective function or onto function. Surjective, and this is also traditionally known as onto function, as it is written here, onto function. And when a function is not surjective, then it is termed as non-surjective. Non-surjective. Just we will define this. Traditionally, this kind of function was known as into function. But nowadays into has been collapsed. Nowadays we are not using into. In place of into, we are using simply non surjective function, or this function is not onto. In this way we are expressing to that kind of functions. Okay, so onto function or not onto function is in use in our society traditionally, but nowadays, in place of these two, we say subjective and non-subjective. But now it is essential, this is the time to define the subjectivity, nature of subjectivity of any function. Suppose that any function is of such kind in which no element of codomain, mind it, no element of codomain mean no element of the second set, no element of the second set is unpaired, is unpaired. That means that means we are saying that no element of codomain is not having its pre-image in domain. If it happens, then we say that this function is onto function or subjective function. Without example, it seems difficult uh, to understand. Actually, the words collection in this one is not very good. So, first of all, take an example to make it clear. Suppose that there is a function from set A to set B, then clearly you know that A is called domain of the function, and let this is the B, this is called codomain of the function, codomain of the function F. So codomain of the function, okay, under which suppose that there is an element X which is paired with element Y, then we say that X is pre-image of Y and Y is called image of X. Okay, sometimes it is written as, rather usually it is written as Fx is equal to Y. Fx is equal to Y. Let there is an element inside this set B and Z, and there is no pairing of this element Z. That means we want to say that this Z, this Z belonging to B has no pre-image image in A. If it happens, then we say that this function is not onto function. But if all the elements of this set are paired with the elements of the domain, then we say that this is surjective function or onto function. In simple words, I would say सेकेंड सेट का कोई भी एलिमेंट अनपेयर्ड होगा तो हम उस फंक्शन को नॉन सर्जेक्टिव कहेंगे. लेकिन if all the elements of the second set, that means codomain, are having its pre-images in the first set, that means all the elements are well associated to the elements of the first set, that is domain, then we say that the function is onto. That means there is no element left inside codomain which are unpaired, which is unpaired. Okay, so you can explain in this way: if any y belongs to B, y belongs to B, any y belongs to B implies that there exists some x belongs to A such that fx is equal to y. That means if there is any element inside this codomain, for that one we are getting corresponding pre-image in A, then we say that this function is onto function. That means this element that is belonging to codomain B is having, or you can say is an image of at least one element of the set A, that is domain of the function. If it happens, then we say that the function is onto function. Another way to express this one: Another way to express this one, I am taking an example to make it clear again. Suppose that a and b, these two sets are given, and the function is from a to b. Function is from a to b as this. Okay, function is from a to b as this. Let elements let elements of a are 1, 2, 3. Elements of B are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now this function is defined in this way. Function is defined in this way. Fx is equal to x square. Then you know clearly this one is associated to 1. Okay, and this 2 is associated to 4. This 3 is associated to 9. So you can say that f1 is equal to 1, f2 is equal to 4, f3 is equal to 9. Okay, so clearly 1 has its image as 1, 2 has its image 4, 3 has its image 9. Mind it, mind it. Here, so many elements are present in B which are having no pairing with the elements of A. So you can say that there are so many elements belonging to B which are not images of the elements of domain. Okay, that means you can conclude in this way that range of the function is sometimes written in this way. Range of the function range of any function f can be symbolized in this way also, rf or fa. I have written fa. Never bother about it. You may use any of the symbols written there. So range of a, f is equal to b, is equal to b. Then we say that this is then we say that f is onto or surjective. Okay, onto or surjective function. So clearly we mean the same thing, that there is no element, if there is no element inside the second set codomain which is unpaired, then we say that it is surjective. But if range of the function is a subset of codomain, that means subset of codomain means B is having at least one element which is not in the set FA. That means there is at least one element in B which is not image of any element of A. If it is there, then we say that F is non-surjective. Okay, or sometimes you can say that not onto. Okay, traditionally it was known as into, but nowadays into is not in use. Okay, so you can say that this is not onto function, this function is non-surjective, like that. Now we will discuss how if any function is asked to check is this surjective or not. That means if surjectivity of any function is to be checked, then how we should react, how we should proceed. Now we are to discuss about that. In this process, we are having some questions to make the points very clear. Make the points very clear. First one is, I termed here analytical process, analytical method. That means actually we want to say that for onto we want to say that there is no element in codomain which is not an image of at least one element of domain. We want to say this one. And to establish this one, we have a traditional way, a very analytical approach is there. Analytical approach, that means having some analysis in this process. So, having that one, firstly, we would like to put the steps, and I have written here, it is already written here, and I will make it clear one by one. The first step is this. First of all, we suppose fx is equal to y. First of all, we suppose fx is equal to y, and later on we replace fx by y. Okay, have a question like this, or another question I would like to have. I'm picking a question from the list what I am having here. Okay, leave that one. Leave that one. I'm picking one question that will be good enough to understand the process of finding, the process of finding. Let any function is given as this. Fx is equal to x minus 1 by x minus 2. Suppose that this function is given, and function is from a set of real numbers to a set of real numbers. Now tell me why we have eliminated this 2 from the domain. Very simple answer is this. Very simple answer is this. If we want to eliminate, if we want to say that this function is a real function, and if we put there 2, then it won't be a real function. So make it real, we need to put any number apart from 2. So for the domain part, this 2 is eliminated. And now before putting the value, I want to know, I want to put something here, and later on I will put there what will be the codomain of this. That means we want to have a set of real numbers in which something will be eliminated so that the function will be defined. And this part I am not writing here. First of all, I will make it, and then I will put there. First step, we will suppose fx at 1, and later on we will write the function in terms of y. So it will be equal to y is equal to x minus 1 divided by x minus 2. And the third step says that write x in terms of y. So now write this x in terms of y. So now multiply this x minus 2 to the y, it will be xy minus 2y is equal to x minus 1. And because you are to find x in terms of y, so separate x from the expression. So take 2y this side, xy minus x is equal to 2y minus 1. X is taken as common, y minus 1 is equal to 2y minus 1. So x is equal to 2y minus 1 by y minus 1. Now it is very clear that whenever y will be equal to 1, there won't be any x. So in the codomain part, there should have been r minus 1. That means all real numbers excluding 1. So now this question is complete, and we are talking about the way to handle, by which we will handle the question to check the surjectivity of the function. First of all, we put y in place of fx. So it is written here. In the second step, we are to rewrite the function using y. So we have written in place of fx y and rewritten the given function, this one. And now in the third step, it is suggested that we should write x in terms of y. That means x should be the subject of the expression. Then for that purpose, we multiplied, we simplified and taken all the x to one side and got the value of x is equal to 2y minus 1 by y minus 1. Okay. Now we have to check. The main part was this. Check whether y belongs to B. Does exist one or more x belongs to A? That was the main purpose behind the steps. Behind taking the steps, the main purpose was to check whether all the elements of codomain are paired or not. Whether all the elements of codomain are paired or not. Are images of some elements of domain or not. So for that purpose, we are to check this expression having this one in our mind. Having this one in our mind. Mind it. Here, what is codomain? Codomain. Codomain of the function. Codomain of the function is r minus 1. Means all the real numbers excluding 1. That means if we suppose y is belonging to the codomain, fx is equal to y, that means image of x is equal to y, that means this y belongs to codomain. So if we suppose that this y is belonging to r minus this, then you are to check having this value of y, having that value of y, we will get some value of x or not. And if we get some values of x, then we are to check whether those values are in set A or not, in the domain part or not. So two things. Firstly, primarily you are to check whether for all y's this expression is meaningful or not. That means you are getting any real value of x or not. Secondly, if you are getting any value of x, does the value or values, maybe one or more value, does the values are in the domain of the function or not? That means the values of x, maybe one or more, are in this category or not, in this domain or not. Here domain of the function is r minus 2, that means all real numbers excluding 2. Okay, so these two parts of this must be checked. Clearly, if you want to check it, first you think, if x is equal to 2, why we took x is equal to 2? Actually in the domain part there is no 2. We want to check it whether the answer will come 2 or not. If the answer will come 2, then in the first instance we will feel that it's correct one, all y's of codomain are paired. But that is not true, because if suppose that the value of, for any value of y, if we get x is equal to 2, for any value of y, if we get x is equal to 2, then is there 2 in the domain? No, not at all. There is no 2 inside the domain. So it must be checked whether for any value of y will we get x equal to 2 or not. So first of all you think x is equal to 2 and put it in this one to get the value of y. Now putting in this one, 2 is equal to 2y minus 1 by y minus 2, we got 2y minus 2 is equal to 2y minus 1, we got minus 2 is equal to minus 1, that is 2 is equal to 1. That is not true. That means for any value of y, we cannot get x is equal to 2. So the crucial part is now over. And clearly for all values of y excluding 1, we will get a real number. So there is no 2 as x, and there is any, for any value of y we are having real number, that means we are getting real numbers excluding 2. So we can conclude that for all, this symbol is for all, this symbol is for all y belongs to this codomain, this codomain r minus 1, r minus 1. We got we got, or you can write there exists, this symbol is for there exists x belongs to the domain part r minus 2, domain part r minus 2. That means for all values of y, for all values of y we are getting real values of x, and in that list there is no 2. That means we can conclude that for every element of codomain we are getting elements in domain. So all the elements of codomain are images of the elements of domain. So we can conclude that therefore this function is onto function. This function is onto function. Onto function, or you can say surjective function. Okay, and finally I would say that if any function is if any function is 1 1 as well as onto, then this function is termed as 1 1 onto or bijective function. So bijective function means means bijective function means bi means two. So bijective function means it is at the same times injective and surjective, or you can say that it is 1 1 onto function. If any function is 1 1 and onto, then we say this function is bijective, or in other words, in modern time technical terminology system, according to that one, we can say that if any function is injective as well as surjective, then it is a bijective function. And I hope you could understand the topic. You can find, or you can check any function as onto function or surjective function. In the next video we will talk about, or we will discuss some more questions. Thank you and have a nice day.